Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.5, Problem 13. This is Section 2.5, Problem 13. It says divide the fractions, and we have 5/8 over 3/16. So in the form that you see it in now, it's what you call a complex fraction. You have one fraction over another fraction. The first thing I'll do is just write it as a division problem. So you have the top fraction, which for this problem is 5/8, divided by the bottom fraction, which for this problem is 3/16. So already it looks not as nasty as it did a second ago. Now what you do to divide any fractions, I will leave the first fraction as is. It's 5/8 in the beginning, it'll stay 5/8. Change the division to a multiplication, and then invert the second fraction. It's 3/16, so when you invert it becomes 16/3. You just flip it, really. Now you're going to multiply top times top, 5 times 16, bottom times bottom, 8 times 3. Now where these numbers are starting to get sort of big, 5 times 16, I notice that I can pre-reduce, and I'd rather reduce now. I can reduce at the end after I multiply and get the same answer, but where the numbers are big, let me reduce now. 8 goes into 8 once, 8 goes into 16 twice. That'll make the numbers easier to work with. So now top times top, I have 5 times 2, which is 10. And then bottom times bottom, or denominator times denominator, I have 1 times 3, which is 3. So I have 10/3, and that is the answer. Some math teachers, some books don't like you to leave your final answer as an improper fraction. If they don't specify, then 10/3 is good. But if they would rather see your answer as a mixed number, what you do is you divide the denominator, in this case 3, into the numerator, in this case 10. And let's see, 3 will go into 10 3 times. 3 times 3 is 9. And then 10 minus 9 is 1. So the remainder of 1 is my numerator. And the denominator, which was 3, stays the same. So the answer is 10/3, or if you prefer, 3 1/3.